In this lesson, we are going to start putting all the pieces together with Calc, with our first derivatives, second derivatives, and try to build as accurate a graphs as we possibly can. Right. So things that we need to consider. When you're looking at trying to put all the pieces together, we should consider whether your function has any domain issues, any intervals, if there's some symmetry on it, which might kind of save some work along the way. Our first and second derivatives are going to tell us when the graph is increasing, decreasing, whether we have some maxes and mins, concavity, inflection points, any kind of critical points. So taking these first derivatives and second derivatives and setting them equal to zero, or where we have things that are undefined within the slopes of first derivatives and second derivatives. When you have increasing and decreasing specifically is when you have slopes that are greater than zero, slopes that are less than zero, and then your concavity is greater than second derivative, greater than zero, concave up, and then less than zero, concave down. Your extrema is potentially where you have a slope equal to zero. But remember, it could be kind of a chair look where the graph levels off but keeps on going in a certain direction. And then set equal to zero inflection points. Also, just because it equals zero doesn't guarantee it's an inflection point. We have to dig in a little deeper. We have some asymptotes, what's our end behavior for our graph. And then just kind of like this is the college algebra pre-calc stuff, like asymptotes, x-intercepts, y-intercepts. If we set the original equation equal to zero, we'll get our x-intercepts. If we plug in zero, we'll get our y-intercept. And then maybe plugging it into a calculator and kind of seeing what's going on. Our scale may be nowhere near what we need it to be. Right, so we may have to be comfortable adjusting the window and kind of getting it out of that kind of 10 by 10 normal window that we think about. All right, so with all that, we're going to practice not so much an equation and doing derivatives and stuff that just give us information, and we're going to take this information and try to build a little bit of a sketch of a graph. Right, so they're giving us from negative infinity to zero that our first derivative is less than zero, and the second derivative is greater than zero. So negative infinity to zero, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So here's what I'm going to start to do. My first derivative stuff, I'm going to start to just kind of build a number line, and I have critical values of 0, 1, 2, 3, and 4. And then I'm also going to add my second derivative and kind of try to line it up perfectly underneath it. 0, 1, 2, 3, and 4. Okay, so what I'm going to do is take that information and put it onto this number line. So we have concavity going on with the second derivative. We have slopes going on with the first derivative. And from negative infinity to zero, it says that our slopes are going to be negative. And then from 0 to 1, our slopes are going to be positive. From 1 to 2, our slopes are positive. From 2 to 3, our slopes are negative. From 3 to 4, our slopes are negative. And from 4 on, our slopes are positive. So if I just kind of analyze that part of it, we have a negative slope transitioning to a positive slope. One thing is the graph is continuous everywhere. So we don't have any asymptotes that we have to worry about. This graph is going to be connected. It's going to be some sort of a polynomial, most likely. But we have a negative slope transitioning to a positive slope. So that would look something like that, where we'd have some sort of a minimum. And then a positive slope transitioning to a positive slope, but we do hit a slope of 0 at 1. Right, so it's not a max or a min. And then we have a positive slope transitioning to a negative slope. Right, it's going to look something like that. So we'll have a maximum. And then a negative transitioning to a negative. That levels off. So we have kind of the chair. And then a negative slope transitioning to a positive slope. Negative slope, positive slope. There we go. So we have a minimum there. All right, so that gives us some information about where some maxes and mins might be, where a chair might be, and then let's see what the concavity is. So, from negative infinity to 0, we have positive concavity, and then from 0 to 1, positive concavity, 1 to 2 is negative, 2 to 3 is negative. 3 to 4 and 4 on are both positives. So visually, we have concave up, concave up, concave down, concave down, concave up, and concave up. All right. Where we have this transition from one concavity to another is actually going to be an inflection point. So that's a critical number. So inflection point at 1, and a negative concavity transitioning to a positive concavity is an inflection point as well. All right, so if I draw some sort of a graph, we're going from 0 to 4. So 1, 2, 3, 4. And this is where I'm going to totally just take a guess. I have no idea the exact values, but I can get a rough idea of the shape of this graph. We're going to have a minimum at 0. And then we're going to have some sort of a chair, which is actually an inflection point at 1. And then we're going to have a maximum at 2. And then another inflection point at 3. And then a minimum at 4. Now, I have no idea which one of these is lower than the other. One of them is going to be an absolute, or both of them could be absolute if they line up at the same spot. I have no idea. I'm just kind of taking a guess. But here's what we got. If we connect these dots, we're going to have concave up from 0 to 1. So there's our concave up, right? And then at 1, we transition to concave down, and that's where our inflection point occurs, right? So that's where we shift from concave up to concave down. And then that happens again at 3. So that's when we shift from concave down to concave up. And then we can analyze all the slopes. We have a negative slope, positive slope, positive slope, negative slope, negative slope, positive slope. So everything lines up. The only thing that I don't know is I just don't know where these y values are. I don't know how high that is, but it's a relative max because it does go up in both directions and behavior-wise. I don't know which one of these are the absolute mins, but we didn't have enough information for that. So that's a rough idea of how I can take all sorts of information, put it into some table, and then take that table and go ahead and build yourself some sort of a rough graph.